Okay. Today we will start to look at the conditional operation. Okay. So last time we looked at the instruction format for arithmetic operation and immediate formats. So there are two formats: R format and I format. And we learn about some instructions which is belonging to the R format, like add instruction, subtraction. And for the I format, we learn about the add, and I, load, store operations, right? So from today, we learn about the conditional operation, control operation, conditional operation, which is supporting if statement. Okay, and also we learn about the go to statement. Okay, in the MIPS, there are two conditional operations which are branch equal and branch not equal. Okay, so these are branch equal and branch not equal. So the format looks like this. The first one is operation name, BEQ, branch equal. And the first one is register name, source register and destination. And last one is label. Okay, so label is actually is a constant value. Okay, so this is constant value. Then can you guess what kind of format is actually used for this instruction? R format, I format, which format are actually used for this instruction? Yeah, this is actually compiled, translate to the I format. Okay, so this instruction is requiring the two registers and one constant value, which is label. Okay, so the instruction looks like this. This instruction is comparing the register value of this source register and destination. So it's comparing. Okay, so this is equal. So branch equal instruction case. If it's equal, then it is jumping to the L1 label location. Okay, so that's all. So for instance, it's like this: branch equal register 1, register 2, and we have to specify the name, like any name is okay. So XX. Then in the assembly, you have to specify that label, just like C code. Okay, so here we are specifying like add instruction. And maybe you can specify some another instructions like this. Okay, so when the first branch equal instruction is executed, if the register 1 value and register 2 values are equal, then this is jumping to the XXX location. Okay. If it's different, then just following instruction is executed. Okay. So branch equal instruction is jumping when two register values are equal, then it's branching. Otherwise, it's not branching. Okay, so the last one is label. Label. It's just like a go-to statement in the C code. In the C code, we are specifying like this: if $1 is equal to $2, then go to X, right? So branch equal instruction is exactly equivalent to the this C code representation. So if with the go to statement, that's the branch equal. Okay. Another one is branch not equal. So it's very similar to the branch equal. The only difference is that the raised values are different. Then this is jumping. Otherwise, it's not jumping. Okay. And last one is unconditional branch. So there is no condition. So this instruction is called jump instruction. So jump instruction case is not looking at any raised value. Always is jumping to the L1 location. So always it's unconditional jump. So J instruction, jump instruction case, it doesn't have any registers, right? So for this jump instruction, we will define another format, which is J format. So we'll look at the J format for this jump instruction. Because jump instruction case, we don't need to specify registers. Okay, so there are three formats: R format, I format, and J format, which we didn't learn about that. Okay, so using this branch equal and branch not equal and jump instruction, we can specify many, actually every conditional things. Okay, so let's look at the first example, which is if statement. So how we can translate or compiling the if statement into the assembly code. Okay, so let's look at this code. So let me write down the code here. So in C code, it looks like this one. If I equal J, then F is G plus H. Otherwise, F is G minus H. Okay, so this is given C code. Then what we want to do is we want to translate into the MIPS code, which is called compile. So we want to generate MIPS assembly code. Okay. So first, for each variable, we have to assign some register, right? Because in the assembly, everything should be through the register. So let us assigning some register for this variable. Let's say this is $1, J is $2, F is $3. So any name is okay. $4, $5. Okay, so we are assigning I, J, F, G, H variable. Okay, then so we have to do, so this is if statement, right? So we have to use branch instruction, branch equal or not equal, we don't know that. So we have to give whether this is branch equal, branch not equal. So we have to compare two raised value, $1, $2. So if these are equal or different, then we have to jump, right? Some location. So any name is okay. It's depending on your decision. So do you prefer the equal or not equal? Can you type your preference? Equal. Okay. So let me write down the equal. So here's the compiler and equal. Equal means if these two values are equal, so ij is equal, then which one do we have to execute? Add instruction, right? So if this is equal, then we have to run the if statement. So let's go to the if. Here we have to specify add instruction, right? So if this is equal, then we have to do add. If $1 and $2 are different, then which one do we have to execute? Subtraction, right? Subtraction. Okay, so if these two register values are different, then just following one is executed. So we have to specify here subtraction $3, $4, $5. Do you think this is complete, or do we need something others? Do you have to do insert some others? What do you think about it? So if we are just executing this code, the problem is that if $1, $2 are different, then what instruction is executed? Different, then subtraction is executed, right? And what's the next instruction in the assembly code? Yeah, add instruction, right? But what about the in C code? If $1 and $2, so I and J are different, then subtraction is executed, right? What about add? Add should not be executed, right? So here we have to insert something between subtraction and add. Because execution of subtraction means that this is different. In that case, we have to execute subtraction only, and we have to skip the add instruction. So to skip this part, we have to add jump instruction. Jump and add something XXX. So here. So branch equal. Then if it's different, then subtraction is executed, but we have to skip the following add instruction. So we have to add some another instruction, which is jump instruction. Okay, jump instruction to skip the add instruction. Okay, so any name is okay. So here we can say that exit. Okay, so if we are using the branch equal, then this code is generated. If we are generating the branch not equal, $1, $2, then what instruction should be generated here? Add instruction or subtraction? Yeah, add instruction. So not equal means it's else case. Else case. In that case, add instruction. Okay, and then else case here. In that case, we have subtraction. Still, we have to add skipping the subtraction part. So we need jump instruction to skip the subtraction. Okay, so that's the if statement. Okay, so when you can write down this code in the simulator, but before we are starting to use the simulator, I want to tell you one thing, which is after branch instruction, so branch instruction means branch equal and branch not equal instruction, and jump instruction. Jump instruction, which is jump here. So after these instructions are called, these are performed. Actually, we will learn about it later, but anyway, currently you just keep in mind that no operation, which is no operation, should be given. Okay, so NOP, no operation. No operation is doing nothing. Okay, so we learn about it, why we have to give this no operation. Actually, in the later, we can give some another instruction rather than no operation. So later we'll learn about that. This is called the delayed branch. So actually, this is not good feature of the MIPS architecture because it's very, I mean, this approach, this mechanism make it difficult to understand the MIPS assembly code. But anyway, this is available. So whenever you are writing the code, you have to add no operation after branch or jump instruction. Okay. So let's try to write down this code in the simulator. Okay, so let's write down the first one. Branch equal one, two, then let's do the if, go to the if, and after branch instruction, operation. Then subtraction, 3, 4, 5, and jump instruction, operation, actually, this is not required, but I just make things a little bit looks better. And here, okay. So then let's look at what is happening. Okay. So currently it is running the first line. And if we are stepping, is it equal or different? That's equal, right? Because $1 is contained in 0, $2 currently is contained in 0. So these two values equal so that it will be jumping to line 6. So let's look at what is happening. Okay, so always the next one is 1. So anyway, so line 6 is actually executed, right? And okay, so $4, 6, 5, 7. Then you can see that $3 will be 30. Okay. Branch and the operation is doing nothing and jumping to the line 8 if statement. So now it will be changed to D. Okay. So it's your turn. Instead of using this branch equal, just use the branch not equal. Not equal, write down the code. Same code. And then if you are completing, please upload your code in the chat window. Okay, any question about this branch equal, branch not equal? So you can follow, right? So it's not so difficult. So then let's look at the loop structure. Label, any name is okay. So you can use little character or it doesn't matter. We don't care about that. Even this is not matched, I think it's okay. I think this is also okay. So it is not differentiating the capital or little, I think. Yeah, it's not. You don't care about the label things, okay? Name. Okay, so then let's go to the loop structure. So how we can implement loop structure using this branch equal, not equal, and jump instruction. Okay. So in the MIPS, there is no full loop instruction. Okay, only using jump instruction, branch equal, and branch not equal, we have to make loop structure for loop or while loop and any loop. So how we can do? So let's get the while loop. While loop. So $1 is less than 5, then it is increasing $2's value. Actually, this is not so good code, but anyway, how we can generate the assembly code. Okay, we have to change into the if something go to statement. Okay, so first we have to change the while loop into the if something go to statement. Here it's totally depending on your thing, your decision. So if $1 is less than 5, then we will do this one. Otherwise, we have to go outside, right? So what we do is, if we are checking something and this is not satisfied, we are going to outside of the loop. Okay, so we write this code. If this is not satisfied, we are going outside. Otherwise, we will keep going about the for part. So here we will increase $2 value. And then in general loop case, we are going to the some location, loop location. So here we are giving the label loop. And then exit is located outside of location. Okay. Then we only have to do is we have to give the condition. The condition is $1 is less than 5. If $1 is reaching to the $5, then we have to go outside. So $1 is equal to the 5, then we have to go outside, right? So the left loop code is exactly the same to this expanded code, right? If $1 is an integer value, then it's exactly the same. Actually, this is not exactly the same, right? Because $1 is 6. In this case, this is not going to work. So I'm just a little bit changing it. So instead of this code, let me change code like $1 is not 5. Okay. So $1 is not 5, then we are doing this code. $1 is not 5, we are doing this code. Okay, so currently we didn't learn about some instruction, this instruction, so skip this part. Then we are generating the MIPS code. So we are compile. Okay, so how we can compile it? So the first code, first line, we know that which instruction do we have to use for that one? Loop, yeah, branch. So here, this code is $1 is equal to the equal to the 5, then it's going to the exit. So this is equal or is not equal? Yeah, this is equal. So we have to use equal. Branch equal $1. Okay, this is constant value. Then we have to go to the exit. So branch equal case, can we specify the constant value here? No, right? Because last one is already constant. So in the I format, second one should be register, right? So we have to store 5 into the register. So we need, for instance, $2 is including number 5. So we are giving the register name here. Okay. This is $3. Okay. So $3 is containing value 5, and $1 and $3 are equal. Then this is exit. Otherwise, $2 is increased. So add I $2 by 1. Okay, and then go to implement the go to, which instruction do you have to use? Yeah, J. Jump instruction and go to the loop. Okay. And after jump, exit should be located here. And after branch instruction, we are putting no operation. After jump instruction, we are putting no operation. Right? Maybe you can specify this loop label here, but we already know that $3 value is not updated, right? So it's a constant value, so we don't need to update $3 every time. So $3 is not updated in the loop, inside the loop, so we don't need to include that $3 assignment in the loop. Okay, so then can you write, if we are running this code, so can you write this code in your simulator? If you are completing, upload your code in the chat window. The first one at I. So if you're running this code, then you can see that $2 value is increasing, right? I learned once already. So $2 value is increasing and jumping to the original location loop structure. So you can see that $2 value is increasing. Okay. So then simply, can you write the code? Then can you write assembly code for this C code? While $1 is not 5, then $1 is increasing. Initially, $1 is 0. So can you write down this code? So what's the MIPS assembly code? Okay, I think everybody is already almost done. So first, we have to initialize $1 value. And then 5 should be stored in some register. And then loop structure. Branch, if it's equal $2, then we are exit from this loop structure. Otherwise, $1 is increasing. Okay, so this is code. Okay, so then another one, $1 is 5. $2 is 0, while $1 is not 0. Then $2 is $2 plus $1, and $1 is decreasing. So can you write the loops code? And then after you're learning what is the $2's value. $1 and $2. So upload your code and also $1 and $2's value. Okay, so we have to initialize $1, $2, and loop structure while loop. So we need loop structure. Range equal $1 is equal 0. 0 is 0 register. Then we are going outside. Otherwise, $2 is updating. And $1 is decreasing. So we can use that I -1. And operation is required here. And then jump to the loop. Okay. So this is the code. Okay, then let's look at some. So we learned about the two instruction, branch equal, branch not equal, right? But what about that if we are compare? So for instance, if $1 is less than 5, like a comparing. So is there a branch less than or branch greater than? So these instructions, what about these instructions? So these instructions are not supporting in MIPS. Okay? MIPS only supporting two branch instruction, branch equal, branch not equal. So for this comparison, there are some different instructions available. Let's go to the location here. Okay, more conditional operation. Okay, so we only learn about the two instruction, branch equal, branch not equal, but sometimes we want to compare it. So in the case, there is one instruction which is set on less than. Set on less than. Okay, set on less than. So this instruction is R type instruction, R format. So which means that there are three registers: destination, source, second source, just like the normal instruction. So what this is doing is it is comparing two registers. Okay, so comparing two registers, RLS, RT, and comparing the less. Okay, then if this is true, then all this 1. If it's false, then all this 0. Okay, this is doing the Boolean operation. So RS is less than RT, then destination is 1, otherwise destination based value is 0. Okay, only comparing. That's all. This instruction is available. Then maybe you want to comparing register $1 is less than 5, right? So in this case, this is constant. So there is set on less than immediate. So in this case, 2 register and 1 constant. So here, source register is comparing with constant and result is stored into the RT. So RS is less than constant, then RT is 1, otherwise RT is 0. Okay, so using this set on less than instruction and branch equal and branch not equal instruction, we can do everything. Okay, so for instance, if if $1 is less than $2, then we want to go to the exit. Okay, so in this case, this one can be compiled into the two parts. First, we have to comparing. So compare means we have to set on less than instruction. $1, $2 is comparing, and then result is stored into the sum register. And then which instruction do we have to use? This instruction is looking at the $3 register and 0 register, and then exit. So branch equal or branch not equal instruction. Which case do we have to go to the exit? If this is true, right? This is true. True case, we have to jump. Right? True means that $1 is less than $2. In that case, we have to jump. So if $1 is less than $2, then what's the $3 value? Maybe if it's true, then it's 1, right? So if $3 is 1, in that case, we have to jump. So this should be not equal. Because $0 is containing 0. The $3 is equal to the $0. That means $3 is a 0 case. In that case, we have not to jump. So if these are different, $3 is different, $0, then we have to go to the exit. Okay. So combining this code with the set on less than and branch equal and not equal, we can specify many loop structure and if statement. Okay, then let's go back to the example. Okay. Okay, so originally it was $1 is less than 5, right? So $1 is less than 5. So which instruction do we have to use in this case? To comparing this $1 and 5, we have to use set on less than immediate. Okay, so $1 and 5 is comparing and result is to be stored into the some other register $3. Okay. So what is happening is what we have to do is we have to comparing set on less than $1 and with 5 and result is stored into the sum register, and we have to call branch instruction, right? So branch instruction, branch something, and comparing 3, register 3 with register 0, and we have to go to the exit. So which instruction? Equal or not equal? $3. Okay. $5, $1 is less than 5, we are remaining in their loop. If $1 is less than 5, it's not true, then we have to go outside. So if this is true case, we have to stay in the loop. If it's false, false means it's 0. In that case, we have to go outside. Okay, so it's your turn. You have to write down this code in the simulator. And then run this code. And if you're writing the code, then please upload your code in the chat window. So you have to remember that branch instruction and jump instruction are control operation, but set on less than is just arithmetic operation. Set on less than is not branch instruction at all. Just arithmetic operation. Arithmetic operation. So set on less than case, we don't need any no operation at all. Okay, I think you can do it. Okay, so then let's go to the exercise 1. Let's look at the loop code 2. 4. So this for in C code 4 case, what we have to do first? $1 is initialized by 0, right? And then we are checking the condition. If this condition is satisfied, we are staying in the loop, right? And then doing the condition change, and then checking the loop. And then if it's not satisfied, then go outside from the loop structure. So if we are compiling this code, can you do it? Yeah, can you write it? So you have to check when you are learning this code, then $2 value should be 45, right? And $1 will be 10. So let's look at the code. Initially, $1 is 0. So 0. And then loop structure. We have to comparing the condition. So set less than I plus 3, $1, 10. And branch, some case, $3 is 0. So false case, then we have to go to the exit. False, that means it is equal. $3 is 0. In that case, we have to go outside from the for loop. And then $2 is updated. And then $1 plus plus conditional thing. This should be running. Then go to the original loop. Let's say this is 4. 4 is here. This is the code. If we are learning, then what is $1's value and $2's value finally? In hexadecimal. It will be A, and this is so let's check. Right. Okay, so then let's look at the first code. Can you write it? So here we are comparing $1 with, so set none less than I. $1 is comparing $0 and store into the $2. So which one do we have to use? $2, $0, exit. Is it equal or is it not equal? What do you think about it? Okay. So when we are looking at this code, the while loop is remaining, $1 is greater than or equal to 0. Otherwise, $1 is less than 0, then we have to go to the stay, in the stay, right? So $2 is not less than 0, then go to exit. Okay, so $1 is not less than 0, then outside. No, it's not right. $1 is less than 0, then go to exit, less than, right? So this is true. This is true. $1 is less than 0. In that case, we have an exit. So that means $2 is 1. Okay, so whether this is equal, whether it's not equal, you can check. It will be 0 or 1. So you can check, then you know that which is correct result. Okay, so then similarly, you can do the loop code 3, right? You can do it. And also, I think exercise 2 is also. This is just for loop. Just for loop, right? So using the branch equal, set on less than I, and just the computation, then you can write this code also. So I will give exercise 1 and 2 as a homework. Okay. So I will give you them as a homework. Okay, so today we learn about the conditional branch and jump instruction and also comparison operation, set on less than I, set on less than. Okay, so that's all. And last time I was talking about the shift operation. Shift operation. Okay, so in C code, this shift operation is actually representing it will be, someone was testing about that -1 shift 1. This is actually equal to -1. So someone was implementing this code and she checked that this is -1, which means that in C code, this is arithmetic shift operation. Shift operation. Okay, in the C code. Java case, I think these 3 symbol is representing the logical shift operation. These are logical. Okay, so Java is supporting 2 things, 2 shift and 3. So this is arithmetic, and 3 things are logical. But in C code, there is no logical shift operation. So everything is arithmetic operation, arithmetic shift operation. Okay, so that's all. So next time, we'll continue with this conditional branch thing. And exercise 2. Actually, exercise 3 is also possible. You can do it. A little bit complicated, but anyway, we will do it together. And then it will be also homework next time. And then we will look at the combining with the array access with this loop structure. Okay. And you can also implement the sorting things using this assembly code. Okay, so any question? Okay. Someone has the homework. Okay, so what is your question? So what's your question about the homework? You can ask me in Korean also. Okay, someone is asking about the E7. Homework 7. Okay, so here, actually, we didn't know about the multiplication operation and division operation yet. Okay, so we didn't know about these instructions. So here, this case only, so this case only some power of 2, right? So power of 2. In this case, we can implement using the shift operation. Shift operation. So in compiler, actually, in compiler is looking at this constant value. If this constant value is a power of 2, in that case, it is generating the shift instruction rather than multiplication, because multiplication takes more time than shift operation. So actually, it's happening. So currently, we didn't know about the multiplication and division yet. So everything is just implementing the shift operation only. Okay. Okay, so next time we'll continue about this one and also memory layout, and then the last thing will be the procedure call, function call. Another question is about the midterm exam. I didn't decide yet, but anyway, midterm is also online exam. Okay, midterm is online, which means that this is open book. Midterm is open book. Open materials, you can record any. You can also use the simulator also. You can use the simulator and slide everything, but no discussion. So during the exam, you cannot ask question to your friends, okay? So that is not allowed only. So everything is open. And midterm will be, I didn't decide, I will announce next time. So maybe it will be, yeah, I didn't decide yet, okay? Any other question? Okay, then see you next time, bye.